In this video, we're going to do some implicit differentiation practice. So we're going to find dy dx, or y prime, same thing. Dy dx is the same as y prime for the equations below. E to the xy plus x squared minus y squared equals 10. Sine of pi x plus cosine of pi y equals 2. Secant of 1 over y equals x. 4xy plus the natural log of x squared y equals 7. For this, also find the derivative at the point 2, 1. And x plus y cubed equals x cubed plus y cubed. And here, find the derivative dy dx at the point -1, 1. So grab a piece of paper, pause the video, give these a serious try, and then I will go through the solutions one by one. Okay, so we're going to first take the derivative with respect to y. So take derivative with respect to y. So e to the xy, we know by the chain rule that the derivative of e to the something is derivative to that something multiplied by the derivative of the inside function. Here our inside function is x times y. So there's really a product here. It's x times y. Y is some function of x. We don't know what it is. It's given implicitly in the equation above, but we don't have an explicit equation for y. So we need to use the product rule, x times some function of x. So this is the first times the derivative of the second. The derivative of y with respect to x is simply dy dx plus the second, y, times the derivative of the first. The derivative of x with respect to itself is dx dx, which is just 1. So that's the first term, the derivative of the first term, plus the derivative of x squared with respect to x is just 2x, minus the derivative of y with respect to x is, well, y is the inside function, 2 the squared is the outside function, so 2 times the inside function to the first power, that's doing the chain rule, multiplied by the derivative of the inside, and then that's equal to derivative of 10, that's a constant, so that's 0. Okay, so we've taken the derivative with respect to y, and now we need to solve for dy dx. So we need to get all the dy dx terms on one side of the equation. Notice that right now, this term, this times this, is not a dy dx term. There's no dy dx in that term, whereas this term, when these two are multiplied together, does have a dy dx. So we do need to multiply out that e to the xy times that other stuff. So we've got e to the xy times x dy dx is the first term when we multiply out, plus y times 1, so y e to the xy. So again, the first term does not have, the first term does have a dy dx in it, whereas the second term does not have a dy dx in it. Okay, so moving forward, plus 2x minus 2y dy dx equals 0. So now let's get all dy dx on one side, get all dy dx terms on one side of the equation. And so when we do that, okay, I've got which terms have a dy dx in them. The first term has a dy dx and the last term has a dy dx. So let's, I guess, subtract those, or subtract this one and add this one to the other side. So when we do that, we'll have y e to the xy plus 2x is equal to our first, well, let's do 2y dy dx. We added that term over, minus x e to the xy dy dx. So now that all those terms are on one side, we can factor out our dy dx's. We're still trying to solve for dy dx, so we can factor dy dx out of each of the terms on the right-hand side. So we've got y e to the xy plus 2x is equal to 2y minus x e to the xy. Each of those terms is multiplied by dy dx. And now we can divide by the multiple of dy dx to get dy dx by itself. And we have y e to the xy plus 2x divided by 2y minus x e to the xy is equal to dy dx. And that is our derivative, dy dx is equal to y e to the xy plus 2x divided by 2y minus x e to the xy. All right, for this equation, again, take the derivative of both sides with respect to x. Sine of pi x, that's a chain rule where this is the inside function. So derivative of sine is cosine. Leave the inside alone and multiply by the derivative of the inside. The derivative of a constant times x with respect to x is just that constant. Plus the derivative of cosine is negative sine. And leave the inside alone. Again, the chain rule. Multiply by the derivative of the inside. So that's the constant times dy dx, which is not simply 1, it is dy dx, and that's all equal to 0. So now we can, again, solve for dy dx. I'm going to add this term over to the other side to get the dy dx by itself. And so I've got pi cosine of pi x equals pi sine of pi y times dy dx. And now I want to divide both sides by the multiple of dy dx. So I've got pi cosine of pi x divided by pi sine of pi y equals dy dx. And, there's a pi in both terms. Might as well get rid of those. So in the end, I could have the slightly simplified version, dy dx is equal to cosine of pi x over sine of pi y. And that is dy dx. For the derivative of secant of 1 over y equals x, I can take the derivative of both sides with respect to x. Derivative of secant is secant tangent. So I've got secant 1 over y tangent 1 over y times the derivative of the inside. So this inside function. I could think of this inside function if I wanted as y to the negative 1, if that's helpful for me. So then I can use the power rule instead of the quotient rule. So multiply by the derivative of the inside. Derivative of y to the negative 1 is negative y to the negative 2 multiplied by the derivative of the inside. Again, y is a function of x. The derivative of y with respect to x is dy dx. And so that is the derivative of the left-hand side. The derivative of x with respect to x is simply 1. And so let's see. It looks like this is one single term. There's no terms separated by addition or subtraction. So this is one single term. And so I can solve for dy dx. I'm just dividing by everything that's multiplied by dy dx. So dy dx is equal to 1 over y to the negative 2. So, I'll just keep it like that for now. Y to the negative 2, secant 1 over y, tangent 1 over y. And there was also a negative there, so I'll put that negative right there. And if I want, having a negative exponent in the denominator is kind of silly, I can move it up to the top. Negative exponents flip the fraction, so this is negative y squared, secant 1 over y, tangent 1 over y. And so that is my dy dx. All right, 4xy plus natural log of x squared y equals 7. So taking the derivative of that. So first of all, I'm just going to take the derivative in general, and step 2, I'm going to find the derivative at that particular point. So derivative of 4xy, this is a product rule. So it's the first, 4x, times the derivative of the second, dy dx, plus the second, y, times the derivative of the first. Derivative of 4x is just 4 with respect to x, plus derivative of natural log of x squared y. That's a chain rule where this is the inside function. So 1 over x squared y times the derivative of the inside. Again, I'm going to need a product rule for that inside. So it's the first times the derivative of the second, dy dx, plus the second, y, times the derivative of the first. Derivative of x squared with respect to x is just 2x. And that's all equal to derivative of 7 with respect to x is 0 because 7 is constant. Okay, now I want to get all the dy dx terms together. I see that this is a dy dx term, this has a dy dx in it, whereas this other term does not. So I am going to have to distribute this to the other. I'm going to have to distribute this to the other terms to get one dy dx term and one non-dy dx term. Okay, so I've got 4x dy dx plus 4y plus, okay, when I multiply 1 over x squared y times x squared dy dx, I see my x squareds cancel out for that first term. So I've got 1 over y dy dx is what I get when I multiply 1 over x squared y times the first term, plus 1 over x squared y times x. Again, some things cancel out. I can cancel out one of those x terms with one of this x term. I can cancel out this y with this y. And so what I'm left with is 2 over x. And that's all equal to 0. So now I want to collect the dy dx terms on one side. I guess I'll leave them on the left-hand side because they're already there. So I've got 4x dy dx plus 1 over y dy dx equals negative 4y minus 2 over x. Subtracting those over. And now I can factor dy dx out by itself. So I've got dy dx multiplied by a 4x plus a 1 over y is equal to negative 4y minus 2 over x. And now solving for dy dx, dy dx is equal to negative 4y minus 2 over x divided by 4x plus 1 over y. So that is my dy dx. I was also asked to find the derivative at a particular point. That's just plugging in our values for x and y. So this is the point x, y, and I'm just plugging those values in. So dy dx evaluated at the point 2, 1 is then equal to negative 4 times y is 1, minus 2 over x is 2, divided by 4x, x is 2, plus 1 over y is 1, and I can simplify that. I've got negative 4 minus 1 divided by 8 plus 1, so that is negative 5/9. So negative 5/9, I could also find the decimal equivalent of that, but negative 5/9 is my derivative of y with respect to x at the point 2, 1. Okay, last one. So taking the derivative of both sides, here this is a chain rule where x plus y is the inside. So we've got 3 times x plus y to the second times derivative of x with respect to x is 1 plus derivative of y with respect to x is dy dx equals x cubed's derivative with respect to x is 3x squared plus y's derivative is 3y squared times the derivative of the inside, derivative of y with respect to x. And so again, I've got one term that's a dy dx term and one that is not added together. Therefore, I must distribute this. So I'm going to keep it as 3x plus y squared times 1, which is just itself, plus 3 times x plus y squared times dy dx. And that's equal to 3x squared plus 3y squared dy dx. I'm going to get all my dy dx terms on one side. So I guess I'll subtract this over and subtract this over. 3 times x plus y squared minus 3x squared equals 3y squared dy dx minus 3 times x plus y squared dy dx. And now I've got, let's see, I can collect my dy dx terms together and factor. So 3 times x plus y squared minus 3x squared is equal to dy dx times 3y squared minus 3 times x plus y squared. And now solve for dy dx, divide both sides by the multiple of dy dx. 3 times x plus y squared minus 3x squared divided by 3y squared minus 3 times x plus y squared is equal to dy dx. All right, so there are things that could be done here. One very obvious thing is that 3 is a multiple of every single term, so I could write this as x plus y squared minus x squared divided by y squared minus x plus y squared. At this point, it's kind of, you could leave it like this and that would be fine. You could also multiply out. X plus y squared is x squared plus 2xy plus y squared minus x squared divided by y squared minus x squared plus 2xy plus y squared. And some things do cancel out. That's equal to x squareds cancel out here, y squareds cancel out there. So we're left with 2xy plus y squared over negative x squared minus 2xy. So we could leave it at that point. Either way is fine. And we were also asked to find dy dx at a particular point at negative 1, 1. So at negative 1, 1, again, we're just going to be plugging in our x value and our y value. And so we've got 2 times 1, or 2 times, negative 1 times y is positive 1 plus y squared, 1 squared, divided by negative 1 squared minus 2 times x is negative 1 times y is positive 1. So that then would be 2 times negative 1 is negative 2 plus 1 over negative 1 squared is positive 1, but then a negative out front. So that's negative 1 minus a negative, so plus 2. And we're left with negative 2 plus 1 is negative 1 divided by negative 1 plus 2 is positive 1. And we're left with negative 1 is our derivative of y with respect to x at the point negative 1, 1. So dy dx evaluated at negative 1, 1 is negative 1.